Some creatures seem to break the unwritten rules of life on Earth. And understanding these anomalies often leads to discoveries that make us rethink the rules of nature we thought we knew. The forests of the Caribbean are home to some of the most charismatic inhabitants of the American tropics, the Anoles. Anoles are small, tree-climbing lizards with a unique twist, a boldly colored flap of skin on the throat called a dewlap that they use to communicate. Males use their dewlaps to advertise to potential mates nearby, often adding push-ups to their displays. If a female is impressed, she might allow the male to mate with her. Males also flash their dewlaps to defend their territories against rival males. If these displays fail to deter an intruder, the encounter can escalate into a violent battle. The dewlap acts as a kind of ID badge, allowing anoles to recognize potential mates and rivals, while ignoring individuals of other species. According to this explanation, species living side by side should never share the same dewlap color. But two species seem to defy that logic, Anoles cooki and Anoles cristatellus, which coexist in southern Puerto Rico.
They're so similar that for a while they were actually described as the same species.
To the human eye, the dewlaps of these two species both appear orange. So how do they tell each other apart?
Anoles are what we call tetrachromatic. So they got 4 photoreceptors. The human have 3.
Humans can't see UV or ultraviolet light, but anoles can, because they have a 4th photoreceptor sensitive to short wavelengths. A plant or animal that looks one way to human eyes may look very different to an anole. To look beyond the limits of human vision, scientists measure the full spectrum of light that an object reflects.
The green is the reflection of the dewlap of cristatellus, and you can immediately see this big bump of reflection in UV. That means that the dewlap of cristatellus have a big area where UV is reflected. And now if you look at that and you look at cooki, it's actually flat. So that area of reflection in UV on cristatellus is not present on cooki. So if you don't see UV, these things will look very similar. If you see UV, it's like black and white.
These two species can readily tell each other apart, even though humans can't. But why do they differ in this part of the spectrum that humans can't see?
Let's make it simple and forget about color for a minute. Let's think about black and white.
Cristatellus and cooki coexist in the dry forests of southern Puerto Rico. This is the stronghold of Anoles cooki, and in this dry environment, sand and rocks reflect UV light.
A high UV environment is a white environment, and you want to have a dewlap that works, or a signal that works. Which color will work? Another white signal or a black signal? The answer is black. So you can shine a lot of UV in the dewlap of a cooki, nothing gets reflected, it just turns black.
Anoles cristatellus lives alongside Anoles cooki in these dry habitats, but most of its range is lush forest. Here, plant life absorbs UV light, and anoles experience a totally different light environment.
There is less UV, so it's sort of black. And now you have a flag that is white. So it becomes highly conspicuous.
Each species is most eye-catching in its own preferred habitat. Where the two species overlap, The same UV color differences that make them stand out against different backgrounds also enable them to tell each other apart. By studying anomalies like these two look-alike anoles, scientists are learning about more than just lizards. They're gaining new insights into how the environment shapes the evolution of animal communication.
In my case, why I study what I do is because myself, I'm a natural historian. And I began as a kid going outside, and I was fascinated by nature. Many of the questions we have not addressed yet are waiting to be addressed, are out in the forest or out in the ocean, waiting for somebody to go out and take a look.